We didn't record using the Pythagorean theorem. We'll just have to include that on the DVD bonus material. And then we'll have director's commentary for why that scene shouldn't have been cut. And then the actor will explain why it needed to get cut. And it needed to get cut because the director is pretty forgetful and doesn't always hit the fourth button. So it'll be a super mundane expression, but we'll make a super clickbaity title on YouTube Shorts. You'll never believe why the director cut this scene. And then the video's like, oh, he forgot. He just forgot. Well, that's super underwhelming. And then YouTube will be like, oh, it doesn't matter, you clicked. Here's an ad. What are we talking about? Oh, yeah. What do we have to use to find an angle and with all these trig functions? What do we use? Inverse. Awesome. So we're going to do a tangent inverse of 8.3 over 11.5. So I need a tangent inverse. Those are the second functions. So second tangent inverse, 8.3 divided by 11.5. I'm going to close parentheses because I'm trying to build good habits, not be like all sloppy and not closing my parentheses. When you win 20 in the show, you can leave your parentheses open. People will think you're colorful. Until then, it means you're a slob. 35.8, let's round to the nearest tenth for reasons. So that's how we can find alpha right from the get-go. Alpha can be the first thing that we can find. With that in mind, can we find beta first? What would that look like? What trig function would we use? Tangent again, but we just used tangent. I have to sound incredulous. What? Tangent again? Even though I like totally know what the answer is. So of course we can use tangent, but I want to know if you know. See, that's like the whole game that we played here. So I want to say the tangent of beta with beta as our focus. When we're thinking of beta as the angle that we're going to use or find, what is opposite now? Now 11.5 is opposite. Divided by 8.3. It sounds like I'm trying to start a fight in a math bar. What's opposite now, huh? What's opposite now? I don't know why math's got to be so aggressive. I don't know if it's a more coffee problem or a less coffee problem, but I do know what solution I want to be applying. So, like y'all just told me, to find an angle, we use tangent inverse. Well, in general, we use inverse trig functions. Tangent inverse of 11.5 divided by 8.3. And we get a 54.2. What we want to notice from this setup is that we can, in the solving right triangles game, we have lots of choices of what we can go first. One of the things that we want to point out here is that at no point in any of my calculations did I use rounded off information. The advantage we hear of just doing these things, finding everything as if we're finding it for the first time, is that we're just using given information. Using just given information avoids round off error. We can avoid rounding error by using as much given information as possible. So here we can avoid rounding error We can avoid rounding error by using given information as much as possible. Note that the rounding doesn't really come into play if all we're doing is subtracting. If all we're going to be doing is subtracting, then rounding is less of an issue. Because notice that the subtraction that we've got here, we're just subtracting one of these angles from 90 degrees. The two acute angles will add up to 90. So we can just subtract them from 180. So if I've got alpha is 35.8, then I'm not really, even though this 35.8 is rounded, beta is 90 minus 35.8. So beta is 54.2. So rounding is not as much of an issue if I'm just subtracting from 90. 90 minus 35.8. So we don't have to do that thing under the little tag. So we don't have to do the thing where we have to use the ANS key or the answer so that we can use all the digits. Rounding is not going to be as much of a big deal when we are just subtracting. And the same thing happens if we have beta first. If we wanted to find alpha, we'll just take 90 and subtract the 54.2, and that'll give us a 35.8. Because we were finding the given information was either opposite and adjacent or opposite and adjacent. So it depends on what we're given and how we view the given information. So this beta is adjacent to alpha, but opposite beta. This A is opposite alpha, but adjacent to beta. So we were able to use tangent twice. Because opposite and adjacent switched roles. Notice tangent alpha is opposite over adjacent, tangent beta, opposite over adjacent. The opposite and the adjacent switched roles. More likely what's going to happen is as soon as you find two of the angles, just subtract to find a third. The best thing to do is employ the policy. As soon as I have two angles, I'm just going to subtract to find the third angle, because subtraction is easiest. I don't have to really worry about rounding error or anything like that. So that's one of our overall strategies. As soon as we have two angles, just subtract to find the third angle. Yes. Yes. How's everybody okay? Everyone looks super serious. You all look like there's something else going on. We're just solving triangles. It might just be that you're not being super serious. Like, we got this. Everyone is something else. I'm not all down. It's an inordinate amount of time. Is everybody okay? Are you sure? Is it just kind of thinking in that this class goes on for the next 15 weeks? Like, oppressive yet? Crushed by that? We'll have to change that. Interesting. You got next Monday off, so That might be the whole reason that you picked this class. Monday is a holiday for Labor Day. That cuts a math week in half for a Monday, Wednesday class. Like if you had the Tuesday, Thursday class, you don't get that Labor Day killing off half the week. On the plus side, after Wednesday, you have a whole week before the next class. On the minus side, you're just going to forget everything. You're going to come in here on Wednesday after Labor Day, and we're just going to start over at the beginning. Okay, what class is this? Some kind of. That's everybody okay? All right, so this is your project for this week. I know a lot of stuff said is due today, like 1.5 solving triangles, that is due today. But as usual, you always have time afterwards. Any assignments that you've been avoiding and that you have not done yet, they are still available for you to complete for full points. You can't use that as an excuse for not doing your work. You'll be like, oh well, since I missed the due date, I guess I can't do it. Like, I'm not still available. And you're like, oh, you son of a bitch. I was trying to avoid some work. Or not available the whole semester. You just take the amount of stuff that needs to be done and divide it over the number of days that you have, or just do it all in the last week. I don't know. That seems like a bad idea. Ask me how I know. That was my strategy, by the way, when I was a student. Step 1, find out which professor requires the shortest term papers. Step 2, find out when those term papers are due. Step 3, on the day that the term paper is due, ask for an extension, then begin the paper. Right? That seems like an insane strategy, right? But what happens if when you ask for the extension, the teacher says no? Now I don't have to write the paper. I mean, I got to take the whole fucking class over again, but I don't have to write a paper. It was a shit strategy, and I was an undergraduate for 8 years, so don't do that. Just suggestion. I mean, maybe you want to. Oh, that sounds good. I want to be a sophomore for like 3 years. That sounds awesome. No, it's not. It is super not awesome. All right, that's going to do it for today. Finish up the solving right triangles, and then on Wednesday, we're going to take these acute angles and stick them all around the whole plane. That's going to do it for today. I will see you all on Wednesday. Everybody have a good couple of days, and thanks for playing.